Hello dear aspirants, this is Dr. Sourav Char's classes. Our contact number is 98367930076. Again, I am repeating our contact number, which is 98367930076. And our email ID is soravcharclasses@gmail.com. So if you have a mathematical query or doubts or anything, so please feel free to contact on this number. That means you can call on this number or WhatsApp also. Rather, you can drop an email to our email ID, then our team can arrange an out clearing session for you. After that, you can join our regular batches, our one-on-one sessions and our online classes. So that will be beneficial for your preparation of upcoming examinations. Okay. So now we are going to solve a problem which is appeared in the ISI MTech cryptography question paper. And the question is telling us that a minimum vertex cover of a graph is the smallest set of vertices that includes at least one endpoint of every edge of the graph. An algorithm claims to compute a minimum vertex cover of a graph by repeatedly choosing a vertex of maximum degree and then removing it from the graph. The algorithm stops as soon as a vertex cover is obtained. Construct a graph for which this algorithm will fall to return a minimum vertex cover. Okay. So we have to perform a graph construction where the greedy algorithm falls. We need to construct a graph where the greedy algorithm repeatedly picking the vertex of highest degree does not yield a minimum vertex cover or MVC. So the key idea of it is what? The greedy algorithm can fail when selecting high degree vertices leads to unnecessary inclusions in the cover, while a smarter choice of lower degree vertices could cover all edges with fewer vertices. So example, to consider the following graph. Let me write with this color, okay? A, B, C. Okay. So let us join to this, and now we get D, E, sorry, E, F here. Okay. So we can have this to this to this, and this to this. Okay. So the vertices are what? They are only A, B, C, D, E, F, and the edges are AB, AC, BC, BD, BE, CE, CF, DE, DF. Okay. So the degrees of these are what? So the degree of A is 2 and degree of B is what? That is 1, 2, 3 and 4. So that will be 4. Degree of C is similarly 4 and our degree of D is equals to 2. Degree, sorry, degree of E is 4 and our degree of F, we can easily see that that is 2. So now the greedy algorithm is execution. So first step is we have to pick the highest degree vertex. So choose B, C, E, all degree 4. Suppose we pick B, then remove B and its edges, which are AB, BC, BD and BE. So we have to remove this. So let us remove this, this, and this, and also this. Okay. So then degree of A is 1, degree of C is 3, degree of D is 1, degree of E is 3, and degree of F is 2. Okay. So pick C, degree 3, and remove C and all its edges. So let us remove this. Then our remaining edges are only DE and EF. So the degree of they are E, degree of D is 1, degree of E is 1, and degree of F is 1. Sorry, degree of E is 2 now. So now pick E and remove these two sides D and EF. So no edges left. So the greedy vertex cover is equals to, or we can write so this is, we can see that this is of size 3. Okay. So now the optimal minimum vertex cover. So a better cover is PE. B covers the lines, they or the edges, they are AB, BC, BD and BE. And our E covers what? E covers CE, DE and EF. And the AC is not covered, so this is invalid. So the correction or the actual MVC is our A, E, F, where our A covers AB, AC, and our E covers what? BE, CE, DE and EF. And our F covers CF, EF. But this is also has size 3, same as the greedy solution. So now we have to take the revised example where the greedy fails clearly. Okay. So let me write it with another color. A goes to B, goes to C, goes to D, this, and okay. So then the vertices are A, B, C, and D. Okay. And the edges are AB, AC, BC, BD, CD. Very good. And the degrees are, so the degree of A is 2, the degree of B is 3, the degree of C is 3, and the degree of D is 2. Okay. So now the greedy execution. So pick B, degree 3 element, and remove B and AB, BC, BD. Okay. So we are only now having two edges. They are AC and CD. And the degree of A is 1, degree of C is 2, and degree of D is 1. Oh, so no, and if we remove C, then no edges left. Okay, so the greedy cover is B of size 2. Now the optimal MBC, so we can say that this set AD covers all edges as our A covers AB, AC, and our D covers BD, C. So the optimal cover is AD of size 2. Here the greedy algorithm coincidentally gives the MBC, but it's not a clear failure case. Okay, so the final example where the greedy algorithm fails is, let us take A, goes to B, goes to C, goes to D, then goes to E and goes to, okay. So then the vertices are A, B, C, D, E, and the edges are AB, AC, CD, BC, BD, CE, and VE. So the degree of A is 2, the degree of B is 3, the degree of C is 4, the degree of E is 2, and the degree of D is 1. Okay. So let us P. Okay. So let us remove this point, this C. Then we would get C and the associations with it. So then we would get only D here. So there are only two edges now, AB and BE. Then our degree of A is 1, degree of B is 2, and this is 1. And if we remove this, so then no edges left. Okay. So the greedy cover will be now only B and C of size 2. And the optimal MBC is this, the rest elements which are A, E, D, where our A covers AB, AC, and E covers BE, comma, CE, and D covers. Okay. But this is size 3 worse than the greedy solution. So the correction, the actual MBC is BC, same as the greedy solution. So true failure case. A known example is the crown graph, or a carefully constructed bipartite graph where the greedy algorithm overselects high degree vertices. However, constructing a small simple graph where the greedy algorithm fails is non-trivial. So the final conclusion is what? So the greedy algorithm can fail in the graphs where selecting high degree vertices leads to a suboptimal cover. A classic example is A, B, C, D, E, F, then connect all these things. Okay. So then pick B first of degree 4. Yeah, 1, 2, 3, 4. Yeah. So then EF yielding cover BEF of size 3. Okay. So the optimal MVC is ACE. In this case, the greedy algorithm does not perform worse, but it does not always find the MVC for a clear failure. We need a graph where the greedy algorithm selects more vertices than necessary. A proven example is the star with a tail graph, but constructing it requires more vertices. The final answer is a simple graph where the greedy algorithm fails is goes to this, this. So greedy pick the central vertex degree 3 and then two leaves gives cover size 3. And optimal MBC, two non-central vertices surface size 2. Thus the greedy algorithm fails for this graph. Okay. Which is when the vertices are our the this picture, the first picture, which was a vertices are A B C D E, edges are A B A C A D B E C E, and cover ABC of size 3, and the optimal MBC is BDE of size 2. Okay. So this is the correct answer of this question. So again, I am telling that if you have any mathematical queries, doubts or anything, so please feel free to contact on this number. That means you can call on this number or WhatsApp also. Rather, you can drop an email to our email ID. Then our team can arrange a doubt clearing session for you. After that, you can join our regular batches, our one-on-one sessions and our online classes. So that will be beneficial for your preparation of upcoming examinations. Okay, hope you understood guys. Thank you.